And a couple of months before that, some guys came to me and Fred Wolf and said, "Listen, we want you to work on the physics of Uri Geller, and we'll give you the money." Okay, that was like months before that. And I said, "Hey, just let me finish the story so you get it. Otherwise, you don't understand shit. Okay, you don't get the point." So Monday morning comes, I call up Stanford Research Institute. Brenda Rigg gets on the phone. They said, "Dr. Sarfatti, we were hoping you would give us a call. Can you please come to Stanford Research Institute?" I get in I said, I was only like an hour and a half. I was in Carmel Valley. They're up in, Stanford. Got into the car. First thing, I meet Brendan O'Regan, and he takes me I meet Edgar Mitchell, the astronaut who walked on the moon. Okay. And the rest of it is in this the story. Get the book.
Did you meet John Hadstead at Cambridge? He also tested Uri Geller.
I worked with John Hadstead. He wasn't at Cambridge.
Okay.
He was at University of London. Yeah, I arranged. That's my doing.
Okay, that's why I'm asking you. That's why I wanted to ask you.
Yeah, there's a whole story there. Okay, listen. What you got to do, just get the book, The Great Race. There's a lot of the details are in there. And when
do you have any stories about John Hadstead?
I know. I was at his house.
Okay.
I worked with him. He was the chairman. I was at Birkbeck. I was a research fellow. Well, he was the chairman of the department. I know John Hadstead. Of course, I know him.
All right. I'm just asking then if you know any stories. It'd be nice to get some stories
I know
out.
a lot of stories, but John Hadstead, well, that's the book. Get the book, The Great Race. I think he's in there. But my book, Destiny Matrix, has a lot of John Hadstead. And also John Hadstead go online. He has all the Uri Geller notebooks. He has all the details there.
Yeah, unfortunately, people think, he was wrong. I mean, about Uri Geller. And that's what you think too, right? Like Uri Geller was a scammer.
No. That's complicated. No, Uri Geller does have power. But he sometimes cheats. You can't control it. Sometimes he cheats.
Actually, I will mention this about Uri Geller and too for Charles Crawford, who's also watching. Now, there was a recent interview with Uri Geller on Area 52's channel. He just launched his channel. And Uri actually admits that in that time he was kind of screwed up. And without directly saying it, he kind of admits that he didn't have the power at that time. But he also says that anybody can learn this, and he had to learn it sort of post-haste after his screw-ups. And so he does have it now, but he may not have had it at the time.
He had, I worked with Baharish too. Now, he has power, but at that time, it's a matter of controlling the power. Okay, it's a complicated thing. There's that's a whole other thing. We don't have time. I mean, we don't have time to go. But
it's good to
again, just get the book, The Great Race. Read that book, and then when my book, don't get the book now because I'm updating it. The Destiny Matrix book will have a lot of this stuff. It's a complex story over 80 years. So the thing is, telepathy, all that stuff is real. High strange, it's all real. And
I agree. I know telepathy is real. I trained in it also to finish my master's degree.
You have Russell Targ.
Well, they had this theory that Uri was friends with this guy Puharich, who invented this radio transceiver that could be put in a dental filling.
I stayed at Paharich's house. I know everything about it. I was part of that. Okay, you're telling me I'm a witness to all that.
Yeah, huh?
Yeah, of
what
course.
Can you tell us about all that?
Yes. That's
was Uri using a radio transceiver in his tooth to fool him into thinking he had psychic powers, or?
Well, that's a good question. That they may have done that, but that's not everything he did. Yeah,
right.
I don't know. That's a possibility. Yes.
Well, that's one of the theories because Puharich had this patent. I don't know if you heard about the patent for the tooth.
I saw it. He was showing me all this shit.
Oh yeah, huh?
Of course, I was at his house in Austin. I met him in London. I met him with Uri. I know a lot about Andrea Baharich. Barbara Honegger. Oh no, Barbara. It wasn't Barbara Honegger. It's what's her name? She died. She just recently.
Yeah,
died.
I know who you're talking about.
Elizabeth
Rosher. Yeah.
I lived all that. I know all these people.
So you were buddies with Herbert Bernstein, or did you just go to school with them?
Well, we weren't like bosom buddies. But we went with same classes.
Uh-huh.
We're in the same class. It was a class. We went to parties together. In fact, there's a photograph of all of us. There's a big photograph of the Bernstein twins, a Christmas party of the Last Supper. And I know. Oh, I could tell you one thing though. When we all took the written PhD oral exam at UCSD, and I was second. So I don't know who was first. That's why I found out later. Bob Gould was a professor who says you could cheat on the oral, but you can't cheat on the written. But the reason I was
the opposite way.
I was offered a job as assistant professor of physics at San Diego State down the road from UCSD before I had the PhD, because I was second on the oral exam that year. And Herbert Bernstein took the exam with me, and so did the two Bernstein twins. I mean, not Bernstein twins. The Benford twins.
Oh, really? Oh, yeah. Gregory Benford.
Right. You should read their book, Timescape, because that's about what we're talking about, future to past, Timescape.
Yeah, science fiction.
Yeah, well, that's all because Fred Hoyle used to come down to La Jolla from Cambridge. And this whole thing, the future to past, it's all Fred Hoyle, too. Fred Hoyle, Costa de Beauregard.
Yeah, but Costa, don't you think, I mean, in my opinion, Costa de Beauregard was hung up on invariance.
What do you mean hung up? Everybody's any physicist.
Invariance. No, non-commutativity is not.
Oh, yeah, no. You don't know what you're talking about, okay? Yeah, you're too glib. You're just throwing words around without really understanding it.
Did you ever go to Stanford Linear Accelerator Center?
I went there a few times. Why would I go there? Why would I go there now?
Well,
Eddie had some courses there in summer schools. I went there about 2004, 2006, around that. Yeah, I would go there. I've been there.
Eddie Oceans was hired there to work on non-commutativity.
Oh, who cares? And no, you're sounding a little bit like a crackpot there because you're obsessed. You get
so Slack is crackpot. You think Slack is crackpot?
No, don't say Slack is crackpot. I'm saying you're a crackpot. Slack.
Okay, Luke. What about Luke Hoffman? Is Luke Hoffman?
No, Luke Hoffman's a smart guy.
He collaborated with the Oceans.
Listen, the point is you're taking everything out of context, just throwing words around.
I've corresponded with Luke Hoffman several times.
Write down. Who cares? The point is you're bullshitting. What you have to do, you write down an equation on the board. You say, "Hey, I mean this, and this goes to this." That's the way a physicist works.
Yeah. So you say the simplest is the best.
Well, yeah, but you got to speak the language. You're not, you're just You're just throwing words around. You're throwing jargon around.
So Alon Khan, he doesn't know the equations either.
No, but you don't know them. You haven't. If you knew them, you would write them. You would show them. Say, hey, this I wrote. You go, hey, project. Somehow say this is my theory. I've done this, or this is what they're talking about. When I say non-commutativity, I mean this. Show me the equation. Show me what you're talking about.
You have papers, Drew. Do you not?
Non-commutativity is a very vague term. It means all kinds of things. Basic quantum mechanics is non-commutative algebra. Okay.
Yeah, I know. We already talked about that.
So it's like you're telling me. I mean, you're telling me bullshit. You don't like. It's clear to me you don't understand what you're talking about.
Yeah. Okay. So
you're talking at a superficial level.
So Alon Khan, he has a lecture called "Music of Shapes." Now he is a Fields Medal in math. That's harder to get than the Nobel Prize.
Yes, I know a little bit about that, but it's totally irrelevant as far as I can tell right now.
So you're saying when he gives a lecture called "Music of Shapes" on non-commutativity, you're saying that's irrelevant?
It's irrelevant to the problem I'm working on. Yeah. Unless you can show me, I could be wrong about that, but you have to show me.
Okay.
It's irrelevant.
I'm opening up that window because first you said it's very clear. Now you're saying you could be wrong. That's fine. We'll just leave it at that.
No, what I'm saying is that so what?
So what?
Old fucker. What's he saying? Old schmuck. What's he saying? What is that? What is that there?
Yeah, he also has a lecture for physicists also.
So what? There's nothing to do with physics is a big subject.
Yeah, I know, but Basil J. Hiley said that Alon Khan's lecture to physicists is very relevant.
Yeah, but you want to know something? And nothing Basil's working on is relevant to the problem of reverse engineering to explain how these things fly. It's not relevant.
I sent you the quote on weak measurements being
Yeah, that's
gravitationally repulsive.
relevant, but that's not non-commutative. That's relevant. That's
Okay,
that's
Basil J.
that's
Hiley
relevant.
says weak measurements are non-commutative. They're the same as Bohmian
Everything
non-commutativity.
in quantum mechanics and measurements is non-commutative, so it doesn't say anything. It's not.
Not
It's vague. What you're saying
not
is vague. It's
not
vague.
Basil J. Hiley's not vague.
No, you are. I know he's not. You are.
Okay, go
You're a schmuck,
read
not him.
read Basil J. Hiley. He's not vague.
I've read it. Yeah, no, but you are. You don't know what you're talking
You
about.
haven't read him. I'm telling you, you have not read him. Not his latest research. You need to really study it. It's not vague.
No, I said what you're saying is vague, not what he's saying. What you're saying is vague.
Yeah, sure. I'm telling you to read Basil J. Hiley.
Is that the puzzle? Is that the paper that we showed on the negative mass? Was he in that paper?
No, but he's saying that the weak measurements, he's doing weak measurement experiments right now. He's working with Robert Flack. They're testing argon.
Weak measurement is good stuff, okay? Good stuff, okay?
Yeah, but he says Aronoff is slightly misunderstood about it.
He said, well, they even have little arguments, little details, but that doesn't affect the fundamentals. Yeah, there may be little details in the theory, but that doesn't affect the fundamental picture. Sure.
Okay, so you disagree about the fundamentals with Basil J. Hiley?
No, I didn't know. I didn't say that. I don't know what he says yet. I don't know what because you cannot be precise enough to explain. See, you don't know enough to explain what the points are.
See this lecture, Music of Shapes?
That has nothing to do with anything.
I figured it out in high school.
All right, good for you. So what? How does that
and
help?
Then when I took Herbert J. Bernstein's quantum physics class, I realized it was the same secret as this non-commutativity in music theory.
What does non-commutativity in music theory mean?
Just listen to Alon Khan's video. He
No,
calls
I
it
don't,
he calls it 2, 3. You want the simplest.
Time here. I'm not gonna. I have things I have to do.
I know you don't. You think a Fields Medal math professor is not going to.
If you mean that if you play two notes and then you reverse the other notes, it sounds different. That's non-commutativity. So what?
No, that's not what I mean.
Then what do you mean?
Look, it's.
What do you mean?
Okay. Basil J. Hiley says it's a radical restructuring of physics.
Well,
you want me?
So okay, what? Even if it is, it's probably.
He says he details how Richard Feynman was wrong on YouTube. He points it out.
All right. Well, I'll take a look
with the equations.
Then send me the URL. I'll take a look.
Okay, I'll send it to you. I'll email it to you. I'll put it in the chat too, so other people can find it.
Okay. The point is, this may be interesting fundamental physics, but it will not change. There's Basil. Yeah, there he is. But it won't change what I'm working on right now because I don't need any of that heavy stuff. It's the problem I'm working on is a lot simpler than what he's working on. It's not as complicated. The complications come in the solid state physics, how to make the metamaterials. That part I don't know.
All right, I posted the link where he disproves Richard Feynman.
No, well, I have to see. Yeah, there may be stuff that. I do know that Feynman's stuff is not complete. If you apply the Bohmian picture to the Feynman diagrams, you're going to get extra lines. You get extra structure. Does he say that? Because from the hidden variable, from the particles themselves, see the actual particles, not just
the extra. Okay, I'm just gonna let you study him. All right, I'm not gonna try to be Basil J. Hiley for you. That would do him an injustice.
Yeah, right. Okay, so there we are. Okay, I'm gonna. Yeah, I think I had enough of you, you assholes.
Did you want to talk quickly about what you're working on now with the metamaterials before you go?
I'm not actually doing metamaterial work. There are other people I hope Jeremy should be doing metamaterial work.
Very true.
Eventually, yeah. I'd like to.
If you look at the plasma, if you look at the Lawrence Livermore paper, they have a particular simple model of the S field in terms of the permittivity, the dielectric properties of the plasma. It's not a metamaterial, it's a plasma. Okay. And their dielectric coefficient in their machine, they say, the relative permittivity, it's a pure number, right? Relative permittivity is 10 to the 16 in this plasma. Okay, 10 to 16. And the S field, the thing that amplifies the coupling of electromagnetism to gravity, is the square of that. Basically, I'm simplifying, it's a square. So that's where you get the 10 to 32. 10 to 32. So that S field is basically amplifying the coupling of their electromagnetic plasma fields by a factor 32 powers of 10 bigger than Einstein's coupling, which is G over C to the fourth, which is like 10 to the minus 43 reciprocal newtons of force. So I'm amplified. There's an amplification in their machine, and I'm going by their numbers, of 32 powers of 10. In other words, the Einstein coupling in their machine will be 32 powers of 10 stronger than what everybody thinks it is. Okay. And that will create the warp bubble, and that's what they hope to see. So we need a metamaterial where the dielectric permittivity, relative permittivity, is as big as we can make it. It's got to be at least 10 to, if we can get it 10 to 20, it'd be better. Yeah, that has to happen in a resonance, some kind of resonance, right? When you pump the thing, some kind of force, like a driven harmonic oscillator, damped harmonic oscillator, but with nonlinearities in it. And you want to get a sharp resonance, very high Q. That's what you want. But also, there's this other thing. This is only a simple model. This guy, Keith Wanza, he found that there should be, the S field will also go as 1 over the relative magnetic permeability. So the more diamagnetic it gets, if you get a diamagnetic metamaterial, that should also amplify the coupling of electromagnetism to gravity. So either you want to get a very big permittivity, electric permittivity, relative, pure number, or a very small, as close to zero as possible, magnetic relative permeability. That's what you want in the metamaterial. And I don't know enough. I'm busy working out the warp drive stuff. There's a lot of general relativity that has to be done. I want to do general relativity inside matter. So that's where they come together. But it's a big field, and that's why we need the Manhattan Project. We need we need at least dozens of physicists and engineers all kind of working on. And we need artificial intelligence now. That thing that what's that Prom? Whatever that guy who worked with Brian Graves. We need the artificial intelligence to sift through all the papers and try to find what we're looking for. I'm beginning to use Chat GBT, by the way.
We got Pinecone going, and a bunch of people working on some AI stuff for our group too. So
okay, listen, if you know people, because this guy, he hasn't done it yet, but if you can get some of your people, what we want to do is to take an archive paper, a physics paper, like an archive, and have the AI summarize it and make charts, to summarize, so we don't, so because we have hundreds of papers, we can't read them all, but at least we get some summaries, and then we can see which papers we should focus on. So if you get somebody to have the AI, extract what they think is the fundamental points of the paper, the talking points. There is something that does that, but they're being very secretive about it. They sent me a few, it was not bad, but they just not showing me how to do it. So.
Yeah, so the part of the thing is the cleaning of the data, about putting it in so that the thing can see it and interpret it. The equations thing is a difficult thing for the AI to figure out and navigate currently.
Yeah, I know. That's the problem. But at least they could point to some of the verbal stuff. Then we could look, then look at the equations. I don't know. We'll see.
But yeah, we already have done the work of assembling a really solid database of all the best papers and a collection of all the good data over the years. So we have one of the best databases out there.
But in what? In what field? In solid state physics? In what?
Everything related to everything that anyone can, all the scientists connected to me have ever found in their years of research. We're all sharing it in one big place. It's part of the database project. And if you have data and you're a database guy and you have papers and stuff you want to contribute, please be AlienScientist.
Yeah. Okay. Well, I probably wouldn't mean much to me, but go ahead. What?
Yeah, we have a database team working on that, and we have some AI people who are working with building the Pinecone infrastructure to search the database. and
well, have them look for what you want to look for